Welcome back. In this sublesson, we are going to see how to implement EEM scripts on NXOS switches. EEM, or Embedded Event Manager, is a powerful device and system management technology integrated in NXOS. It provides you with the capability of automating some of the user tasks on the NXOS device itself. EEM takes various events as inputs and enables the user to define what actions can be taken when those events occur. The major components of EEM are event, action, and the EEM policy. It defines the event to be monitored from another NXOS component. Action, it defines the action to be taken when the event is triggered. EEM policy, an event paired with one or more actions to help troubleshoot or recover from an event. An event can either be a system event or a user-triggered event, such as a configuration change. A system event can be an interface flap or a high CPU condition on the device. Actions are defined as the workaround or notifications that should be triggered when those events occur. Actions that can be defined with EEM script are such as executing config or show commands, updating counters, logging exceptions, reloading the device, or printing a syslog message, sending an SNMP notification, executing a TCL or a Python script, or even setting up a default action policy for the system policy. We'll now take a look at how to configure EEM on an NXOS switch. So in order to configure an EEM script, we go into the configure mode. We don't really need to enable any feature for using the EEM script. So we can directly go ahead and say event manager applet named, we can name it test. And what we can do is we can create an event which is let's say it is use the event in the system policy being overridden. So we can use the event, say, and we can match the event with, say, any of the options, like for we can set an SNMP trap or match an SNMP trap, or we can use any of the module level event specifications or fib related event specifications or CLI or counter events. So any of these options that are listed here, we can use those to configure or set the event. So let's say we set an event for CLI, and we under the CLI we can say event CLI, and we can match for a specific CLI. Let's say we can match for restart PIM event, and in that scenario what we can do is we can set the action 1.0 CLI, or maybe action 1.0. We can have different options that we can perform actions on. So we can set either a syslog message, syslog and message, and in the syslog message we can say cannot restart PIM, and we can set the priority action 1.0 syslog priority. We can say it critical, and we are saying the messages cannot restart PIM. So we are setting the priority for the message, for the syslog message, and we are showing it here. And then we can set action 1.1 or action 1.1, and we say conf t. And for action 1.1, we set the SNMP trap, and we say str data and say attempt to restart PIM. So we are setting these options to be taken, or actions to be taken, when the event triggers. So we'll exit, and we'll now say restart PIM. So the first thing, we haven't set the action as event default. That means in case this event happen, the action should let the event to happen. We are preventing that, so it cannot happen. So this the command will be prevented by our event manager policy. I mean, if we modify the event manager policy and say action 2.0 event default, and in that case, and we restart PIM, we should be able to restart PIM protocol, but now the actions will be taken and the PIM process will be restarted. And if you look at our logging history or syslog messages, we can see that a critical message was posted saying cannot restart PIM the first time. And after we configured the EEM script to allow the event default as an action 2.0, it printed the message cannot restart PIM, but at the same time it restarted the PIM process. So this is how we can configure EEM policies. Now we'll take an example, look at another example in which we'll be configuring EEM script and executing a Python script using the EEM. So we have already created a Python script on this switch and saved it on the boot flash. So dir boot flash, and we can see we have the test.py, and we can do more, or we can go into the bash shell to run bash, and we can look at cd space dot slash dot dot and cat test.py. And we can see that we have the import RE, import Cisco, and we are running 3 commands and saving it on the boot flash, right? So we don't have to get into the details of how we configured Python here, but so we have the Python script on the Nexus switch. In this demo, we are going to see how to execute a Python script using the EEM or from the EEM. So for that, we can go into the bash shell. Just to see the script, I created a Python script which is basically just creating a loopback interface named loopback100 and assigning an IP address and performing a no-shut. And what we can do is we can then now create a new script, a new EEM script, say event manager applet, let's say test, and set the event as CLI match, and in the match we can put something as simple as show clock, or even show IP interface brief command output. And once we have done that, we are going to say action 1.0 syslog informational syslog priority, and we are going to say informational and say created loopback 100. Oh, I missed the message keyword. So message created loopback 100, and then I'm going to say action 2.0 CLI local python test.py. And the third important action is 3.0, which is going to say event default. That means let the event take place. So our show clock event does not fail, or show IP interface brief output does not fail. So show IP interface brief, and if we hit enter, we should be seeing our loopback 100 already. So just so you know, we can go ahead and delete the loopback 100, show no loopback 100, no interface loopback 100, and I can go ahead and execute the command again, and there we have our loopback 100 back again. So our Python script is actually kicking in, and it's being triggered as an action by the EEM event that we created. So this is how you can use the interaction between Python, or based on your event, you can execute your Python scripts. Mostly in troubleshooting scenarios, say for an instance you're running into a problem in your network and you're troubleshooting, and the moment you see the problem, you want the Python script to collect some data. And you can set a simple EEM script which is going to point out to the Python script which is going to collect your data for you. So it can come in very handy for automation purposes along with EEM. So you can use and try it out as per your requirements.